So let's go. So thank you to be here. We'll talk about PostgreSQL, like you can see in this slide, and a lot of SQL because both are related, of course. And it's really a pleasure for me to do this kind of presentation because in conferences like this, it's not usual to do something about something which is not hype. Postgres is not hype, but in fact, it's older than me. So it's interesting to talk about something more than 30 years old. So let's start. The story begins in the middle of the 70s when Michael Sandbrecher was the very good team lead of a product, a database engine, and it was successful in production, many customers, but he thought it was a good idea to go back to university to work with talented students to create something new, create something different. And they created Postgres. Postgres, the name, comes from post, something after, and ingress, the first database he worked on. And post-ingress became Postgres. And at that time, 95, we put the year inside the product title, so Postgres 95 appeared. And the year after, because 95 in 96 was not that good, PostgreSQL, they branded it with SQL because SQL was something important, and V1. But they had a lot of past version for almost 10 years. So they rebranded it PostgreSQL V6. And at that time, they started to use version numbering way better than the previous one. Just about me, few things. I'm Kevin, Google Cloud expert on Kotlin and Kubernetes, the cloud. Fan of GitLab CI/CD, open source contributor. I'm working at Gradle, but I'm not working on the famous build tool. I'm working on something else, the developer experience, because our leitmotiv internally is to make developer happier, which is really good when you work there. And we have done a white paper about it because we think the developer productivity engineering is a thing, is something important, and you should leverage it. And we are developing a product called Develocity, which is a way to provide you some insights about your build, your tests, and everything related to your developer experience, in fact. Because if you can't measure something, you can't improve it well. So it's a tool, and I really invite you to use the free SaaS version we have to just discover what your build tool can be improved in some sort. It's compatible Gradle, Bazel, Maven, SBT. So yeah, let's use it. And in this tool, we use a lot SQL. But when I say a lot, it's really a lot. There is many things around SQL and PostgreSQL. And SQL is a structured query language. It's a declarative language, very specific, and it's a bit different than what you know about Java, TypeScript, and everything, because it's a language with a spec. So it means the language itself exists on its own, and there is implementation of this language. And many of them based on the runtime you use, Postgres, SQL Server, or any other. It has been created in 1986, so 1 year before my birth, and the last version is from last year, and in between we had 8 versions of the standard. So if you still think there is no evolution in the SQL ecosystem since SQL 92, you're wrong. There is many new things. I will present many of them today. And the first advice for me when you work with SQL is to remember the order. If you write something, because it's a declarative language, everything is not done like you write things. So in fact, the first thing interpreted by the system is the from join. And everything else here, every steps of the SQL query you can write, is in fact just transformation on the data. So it's a map, flat map, reduce, everything you know from the developer side, it just has another name here, but it's literally just transformation, so nothing else. And write it somewhere if you want to do SQL or just use as a wallpaper in your laptop. It's just the best way to remember it every time. And another thing, we are not in 1992, you don't have to write that. When I see this kind of code, I feel someone is yelling at me because it's all uppercase. You don't have to do that anymore. You can use something like this. And in this whole presentation, it will be lowercase everywhere because it's way better. IDEs are compatible, your engine is compatible, so just use that. And for a good presentation about SQL, we need a good database. And for that one, I choose the Sakila database, which is something made by the MySQL team, but it has been ported to every engine available. It's just a DVD market franchise model. We have many things into it. Everything related to movies, so film, actors, categories, many of them about medias then, and also about the business itself, customer, staff, addresses, yeah, just a model. So it's way better to have a model like this, because if you want to discuss something with another one, we all know this model and we don't know the model you are working on. So everything in this document, this presentation will be done using this model as an example. And the first thing, it's not about Postgres, it's about SQL, because it's something part of the SQL specification. It's the common table expression. We all had to manage this kind of query. You know, this query where we need to read it from the middle and go to the top and the bottom at the at both ends, just to get the meaning of this query. It's like the callback hell we have in many other language. Here it's the same in SQL. It's like that. This example, for in Java or JavaScript, it's the same. If I ask you the signature of every method here, it's hard to read. Even if you have the coloration on parentheses, it's hard. But in fact, everything has the same signature, integers everywhere. So here there is definitely a problem, and it's why common table expression is something good for you. It brings you a better readability. You can extract this embedded query from its original location and put that on the top, just on itself, and use that in the ending query to read it. It's way better to read that like this than the one embedded. And because we have to extract something, like in any other language, we have to name it. And naming things is important. Here, I named it documentary runtails, and I just use that in the ending query by its name. So it's just like an intermediate SQL table available for you. And potentially, as a developer, when I read the thing on the at the bottom, I don't even know if it's an original table or just a thing done by the common table expression. So it's way better, and I don't have to look into the implementation if just the name is enough to understand its purpose. And because SQL again is something declarative, if everything in your common table expression here are totally decorrelated, so I have 3 queries here, they can be executed in parallel. Postgres is not the best one on this part, but it improves after its release. Then the system will be faster, everything in parallel, then everything is gathered at the end, and you can consume that in your ending query. So again, better, because it's declarative. Another big and really big change in the SQL stuff, it's window functions. It's a step we added in 99 in the workflow we had about data. So it's a major change. And thanks to that, we are able now to do things better than before. And because it's done before select, so we have everything after the where, but we don't have to pay every transformation to do that. So just one example. If I ask you to bring the result of the number of movie per rating, okay, I do a group by, you have that. But behind this 194, you don't know which lines has created this thing. It's just a reduce, and you don't have access to the line after. So if I want to ask you, for example, the number of movies globally in the system, you can't. You just have this grouping by, and you can't do anything else. And one thing for that is filter. Filter is a window function we can use. So at the top, you see here the original one, const as all. So I get what I want here, 1000 movies. And I can do something like this on the second and many other lines. Filter, I provide a predicate. It's literally the same predicate you can use at the end of your query as a where rating equals PG. And I do that with PG at the end. Okay, good. And I have the result I want. It's literally the same as the group by before. But now it's just a pivot of the previous result, and I can consume that as one line. Good, a good evolution, but not that drastically different. But I can do that too. Here I'm working on the movie duration, so it's called length in this model. And keep in mind, a movie longer than 3 hours is also movie longer than 30 minutes. So with a group by, could be something very complicated to do because you can't put that in many buckets at the same time. So here we have everything done with that, and which could not be possible with group by. But we can do everything at once. I don't need to do the where and the filter on the same predicate all the time. So I can get everything for analytic purpose, imagine, in the same line, same query, everything done at the same time. So less round trips between your code and your database. Everything is not the database side. It's better for everyone. Again, it's a good thing for your code. Another one, lag and lead. If I say to you, I want in the UI, there is a DVD box, and I want to present to the user of this UI, okay, this DVD box is rented currently by X, and there is someone else who rented it before and after, and I would like to present that in the UI. Usually, we do 3 queries to our system. With lag and lead, it's a way to access the previous line and the next line of the current line we are working on. So let's see it in action. You have too much slide. Here, the first one, we just do the thing we expect. We create the first column, the name of the current one renting the movie. Okay, good, nothing else. And after that, I will be able to do an operation to get with lag or lead. Lag is just before and the other one is after, on a partition. And the partition is on the inventory ID. The inventory ID is, in fact, the DVD box, the physical one. And I would like to get the one renting this DVD box before and after. And then I can have that in the result you see at the bottom. Loretta is the first one because previously there is no one running it, null. And then there is Billy in this example. And we have the same thing for the next line. And after the next line, it's null at the end because I have the full thing. And again, it's a way to get and gather many things in the same query without doing multiple calls, less round trip in your database. And you can extract this other thing from the original query and put that at the bottom with a window keyword and use, so it's a kind of don't repeat yourself, and reuse that in your code. It's very easy to use. Another one, it's the row number. It's a thing I really like to use because I doing a lot of cleaning stuff in the database thanks to it. So let's do that with an example again. I will create a table meant to be used just for this example, film with duplicates. And like its naming mentioned, we'll create things with every movies into it, so 1,000 of them inserted, and then I will ingest 40 of them, but randomly. I don't know which one will be inserted, but 40 of them. So we'll get duplicates. Of course, the system is made for that. And I see that from the result, I have 1,040, and the first one duplicated is adaptation holes. But this one, when you have that in your production, you usually want to remove the one with the higher ID. And if you do a group by on this one, you will lose the ID because it's literally the one you want, but you have to group by on something else, not the ID. And it's not possible to do that with group by. So here we are in a situation where row number can be useful. What we'll do, and what does row number is able to do for you, is something where you'll do a request, and this one will try every time, so it's based on the partition thing here. Partition is about the title. Every time the row number will see a title, it will put 1. If the title is the same, it will put 2. If it's not the same, 1 again. And we do that until we finish the table. So every time I have something duplicated, you'll see that we have here 2. Okay, I can put that in a commentable expression and use that with a delete at the end and just say, okay, everything with more than 1, so 2 here, I just delete them. And 40 rows deleted, it's exactly what I wanted, and I can clean up my system with that. You can use it for many reasons, many purposes, but it's the one I like the most because I clean the database and it's better for everyone. Another case, it's the join lateral. It's a thing not really well known in the PG ecosystem. If I ask you, for each movie, I would like to get the last 3 rentals done. Okay, I just discovered row number, let's use it. I can do this kind of thing. So title and ID, I have the date, okay. I put the row number, like said before. So 1, 2, 3, 4, 5, 8 until the end. So I have all rentals done and ordered and tagged, labeled with the row number. And then I can filter them out to remove everything bigger than 3. So I put that in this commentable expression and I do the filter. So you see, I've loaded everything and then I filter them out. Yeah, it's maybe not what I asked at the beginning. What I want is in fact for each movie, the last 3. Let's do exactly that in SQL, for each. It's not named for each, it's named join lateral. So first we need the list, the movie list. So here from film, we have all of them. And we'll do a subquery. So this one can't be a commentable expression because we have access on the in the subquery to the data from the other table. So it's like every line from the left table is used to generate a different query on the right table. So one line, a new query. So, and here you see we get for each line only 3. So it's more queries, but we don't have to load the whole database. So it's up to you to define if it's the best solution for your use case. It depends on your database resource and the amount of data you have in your database, of course. But here we have the exact same result, but potentially done differently and with the real for each we usually want as a developer. Another one, serial. So we go deeper into the system. Serial, and there is a spoiler on this slide, is evil for me. In this presentation, I use all the time ID serial primary key. It's everywhere in the documentation. It's something common, and it's very simple to use. Here, you see there is an insert, nothing really fancy, except use returning ID title when you do this kind of query, because instead of doing a select after, the system will return what you want, and especially what has been created during this process. Here, it's the ID which has been created by PG directly. And here you see 1, 2, 3, 4. In fact, there is a side effect on this. It's because during the table creation, something has been created called a sequence. And this one holds the data to know which is the last one on your list. Okay, so it means we have a state, a global state in the system called a sequence, which is managed in some way. Okay, global state for me, it's already something wrong. But imagine PG is compatible with clustering. So it means a global state has to be shared between multiple instances. Ooh, got shivers every time I have to say that. It's something wrong at design and infrastructure level. It's why I recommend usually to use something like UUID or just any type of UID, not basing that on a serial like it is by default. And there is drawbacks on UUID, and we'll see that, but yeah, just pick the one you want. This one is for the presentation. So how can we do that? I enable this UID OSSP extension, good, and I have access to this ID type and this ID function here, UID generate v4. So I can create something automatically with this ID. You see at the bottom, the query is exactly the same. No SQL difference between the original model and this one. And in the end, I have that. Okay, UIDs are way bigger than just a serial. So if you have some trouble about the data, the storage you have, maybe it's something to reevaluate, but some other UID can be used for that. But here, what you potentially don't see, there is no global state at the bottom because UUID are generated using the entropy source of your system, so the source of randomness in your system. It's something important, and when this one is not messed up by any configuration, there is less risk for your system to get into collisions than your whole team being struck by the thunder after work in a shiny day. So definitely something you should leverage because we don't have this global state anymore. But if this global state is not here and there is something generated using an entropy source, why not doing that directly from your code in your application? and you can provide this UID by yourself in any type of language, and then you don't have to do this returning ID because you know upfront the future UID inserted in your database. So again, something better if you don't want to consume or wait for the round trip from the database to your code. So again, something I recommend. And on the security side of things, it's also better than serial because you avoid any type and any attack related on the enumeration thing. So someone will craft the ID in the URL and say, okay, if it's 1, 2, 3, 1, 2, 4 is the next one, and then I can try to reach and access something with UID. It's so complicated to get another one. The enumeration attack is not possible. So another one, constraints. Again, we go deeper. When we create tables, there is many things to do, and I really like to protect my model from invalid data. And instead of working on titles here, like I did from the beginning, we can do some and use something well known in the movie thing. It's ISAN. ISAN is like the ISBN, but for movies. It's a unique identifier available for them. And then I can create a constraint here. I can describe it, and you see it's not the regex using percentage everywhere. It's something using POSIX regex. It's with this tilde star or just tilde. It's just not case sensitive in the other case. And then I can check this one using a real and valid POSIX regex. And I can check this one is unique. Okay, got it. I have this case. What is the purpose of that? If I do something really silly and I try to insert a new ID, I'll get an error. But this error is really meaningful for me because I have something saying to me, your system is wrong. Your system is trying to insert something which is an invalid ISAN. And it's very good because first, you don't have to clean your database after if something wrong happened, and you don't have to investigate. It's not string based, it's just a real error. I prefer a real error than cleaning the database again. If I do the insertion twice with the same one, again, I have it's an invalid, it's an ISAN, okay, but it's not, you already have it, so it's not possible to insert that again. But if my system is based on ISAN and I want to share that logic everywhere, I don't want to copy paste this thing all the time. So, and it's literally the reason why Michael Stonebraker has decided to go back to university and create something different, to introduce this idea of types. So we can create a type. Here is just the structure in memory to hold every information required for this ISAN type. And I can create a domain, which is just, as a simplification, the wrapper to add a check to your type at creation time. And then with that, we can create an object. Here, you see, it's an ISAN. Okay, it's not the perfect format you want at the UI level, but memory sake of thing, it's a valid ISAN. Okay, good, I have something. And if I insert something wrong, here, null at the beginning, it won't work. Good, it's already what I expect from this. I don't want to create something wrong. And you can be PG idiomatic and create ISAN to text, text to ISAN, ISAN equals or equals, not equals, and use something really wrong. That, you know, this function inside function. No, you don't use that as a developer already because it's using types, but without the counterpart of it, it's operators. We need operators when we have types. And in PG, you can create your own operators based on procedures or functions as you want, and with any character you want, you can use equals and not equals like in this example, but you can create many of them. And at the end, you have something like this at the bottom with something readable on the left, readable on the right, with something meaningful in the middle as an operator. It's so simple to debug that in production and at any level than a string-based system where you have an error for any reason, if there is any error at all. So again, I really recommend that. It's way better at every level for your application. Another one, and quite recent in fact, it's the merge. The merge has been introduced in PG 15 and in the spec from 2016 of the SQL standards, and it's a way to manage multiple sources of data and merge them into the same table. So let's see it in action again with an example. If I want to provide to my customers a way to ask for a movie to be added to the catalog. Okay, I have my movie list on one end and the requested movie list here, requested films, in the other end. And because I don't want to add two violent movies, I just use the rating as an information because I want to manage things based on it. Okay, we have the model. We insert some data on the requested parts. Okay, we have some movies and one which is way too violent to be added to the catalog. And we have some data already available in the catalog. And I have something very specific in the catalog. The number of time a movie has been requested is just an information, and someone can ask something even if it's already at the catalog because maybe they don't know or they didn't find it. Okay, good. We have this model. So now the merge. We want to merge everything from the requested films table into the other one. It's the idea. And in fact, you already know how to do that. So let's focus on the first part of this query, this part. It's the idea to use and leverage what you already know, a join. It's literally a join. We'll do between the original table and the one where we want to put all the data in. So, okay, face-to-face two tables, and this join will be the way to define, okay, it matched or it has not matched, and then we'll do something different. So here you see the both first movies matched because the condition is based on title. So the first two one are in the other one will do something because they match, and the last two on the left does not match. They don't match. There is nothing about them in the other one. Will do something else. And what we do here? It's part of the second part of this query here. It's with the when keyword. A new one in this context, and the Boolean value matched. So the match part is just the result of this condition with this using and join I just described, and everything you'll do here is in fact as a developer is a big if else, nothing else. And like any big if else is the order matters. If your first if is a catch-all condition, everything will fall into it, and then everything else won't happen at all. So be careful when you write it. Here, when matched, so they exist on both ends, we just do an update using doing a +1 on the requested times. Okay, good. When it's not matched and the rating is R, so too violent for us, we do nothing. Cool. And because again it's ordered, when not matched, but because it's after when not matched and rating R, then it means the opposite. When not matched and not rating R, we just do an insert with the value of requested time to 1. Okay, let's see the results. The ending table, so the movie, the film one, is the two first incremented by 1, and the new one we want, but not the too violent one, which has been just ignored by the system. So it's a way to merge from a source to an ending table, and very useful in the SQL context. So let's go again a bit deeper. Listen and notify. If I say to you in PG, you have a feature which is like some kind of RabbitMQ light to do some message queuing thing. Let's see. I won't describe this trigger because triggers are annoying, but it's just the idea. Every time I will insert something in my table, I will push something into a message queue named film.add. Okay. In action, I have an application using the keyword listen, and listen on what? Film.add. Okay. It's just something, nothing else. There is no result to that. It's just listening on it. Another application will do the insert. Many inserts in that case. And in fact, the other one will receive, it's based on push, not pull. It's not something every 10 seconds from your application. It's really listening and then receiving things. And you'll receive here many information, everything related to the insert done by the other application. So be careful. This one is just good for presentation. Usually you don't serialize something as JSON like I did. It's something where you stream IDs because there is a limitation on the size. So yeah, the best practice, just use IDs here instead of full JSON. But you see, it's something you still can use to stream information to a client of the database, can be any backend, and then this backend can stream that to a UI, to any customer attached to your backend. So almost reactive from application, from database to your client, just with this thing. And it's based on best effort. So if there is any disconnection in the middle, you will lose the data won't get to you because there is a disconnection. So it's why I said at the beginning it's light, but if you need to introduce this constraint at your application level. So okay, I read the table, but I want the events from this film.add queue. It's way better. Okay, another one, again a bit deeper, L3 and more, and that is a case I discovered in production. So not with Terminator, which is for me Terminator 2 the best action movie ever made, but there is something interesting about this Terminator license. It's not linear in this history. We have the 1.34, which are okay, and after that they did a soft reboot for Genesis, and after the first one, and a soft reboot after the 2 for Dark Fate. Okay, so as a customer, if I want to see Dark Fate, what is the list of movie I need to watch before? It's something we can solve with SQL again and with L3. So I can create this L3 extension. Okay, got it. And I have a new type as usual, and saga order. I will describe in the saga order field the path between the current one I'm on and the root of the saga. So in fact it's the opposite, from the root to the current one. So for the first one as an example, it's the root of everything, so it's only 1. You see it here. But for the second one, it's 1.2. The dot is a separator in this case. You can use the name or every information you want, but here I chose to use the ID. And for the sixth, it's 1.2.6. So we have something specific. And with types, we have operators. And here there is this strange operator, which means, in fact, the thing on the left is the ancestor of the thing on the right. So at the top of this commentable expression, we have the movie selection. So here, the fixed one. And then I check for every movies, are they ancestor, the saga order of them, are they ancestor of the current one I'm looking for on the sixth one. So 1 is an ancestor of 1 to 6, yes. 1, 2 is an ancestor of 1 to 6, yes too. 1, 2, 3 is not an ancestor of 1 to 6, so remove it from the results until I reach the end. 6 is, so 1 to 6 is an ancestor of 1 to 6, done. I have the full list of things I have to answer to my customer. Good. But after 1 year in production, I discovered that specific case could have been done without L3 at all. L3, you have many other features to do some star in the pattern and many other things, but just for this use case, I could have used something SQL by default. So instead of the L3, I can use previously here, and it's just a foreign key, but in fact not so foreign because it's foreign to the table itself, with the ID of the previous one. So here, instead of the full L3, I just have the parent. Okay, got it for everyone. And then be prepared, attached to your seat. Here, we have a commentable expression with recursion. And like any recursion, we have 2 parts for it. The first one to launch the recursion. So it's the first part we have here. We select the movie 6. And then we have the second part of the recursion, which will be called multiple times. It's the second part of this union all. So 6 is selected. It goes through the second part. 6 returns 2 because it's the parent. And 2 will enter again in this loop, and 2 will get 1. 1 will get null, stopping the recursion. Everything is done. I have my full list of things. But every time I have to work, it's my kind of thing. My nose bleeds, and yeah, it's hard, but it's part of the SQL spec. It's something you can use even with something else than PG. So really good and really performant. Another one, we go again deeper in this thing with foreign data wrapper. The foreign data wrapper is a way to expose some data not meant to be not SQL at all, and you can expose it with SQL standard. So let's see with a file. Here I just create a table, but it's not a usual table, it's a foreign table. Based on the file, I have some metadata at the end. I will base that on the password file. Okay, good. And the result of that, I can do any SQL request using this table, and you have not seen any insert. It's literally insertless. The thing will automatically parse, manage, return the value for you. If you change the file, of course the result will change, but no insert at all. So you have a source of data compatible with SQL, even if it's not SQL from the beginning. Really good. But we can go deeper again with a program. So first, here, you see the program? Never put something calling curl in it. I know everyone already think about it because it's a way to connect to something else, but here it's just working for security reason, of course, and performance. So here it's possible to do that, but I really advise to do something else in this context. And else is using a foreign data wrapper for the data you want. So as an example, and the only one available by design in your PG distribution is the Postgres foreign data wrapper. It's what is best than Postgres to connect to another Postgres itself. So here I can use with some ceremonial, I declare the foreign data wrapper, the remote cluster, and I'm not talking about clustering. It's really an instance connected to another one, like you directly to your instance. And with some password thing here, and then I can create a foreign table based on this remote instance, and I don't have to respect the original schema, by the way. I can create that with dedicated table and column, and then I can do a select. So performance-wise, it will be slower than a local one. Of course, there is network and indexes and information to improve the query won't be shared between instances, so it's not as good as you want. But in fact, you can operate and potentially do some migration using this kind of pattern between your instances. For example, it's like DB link, but on the foreign on the Postgres side. And you can do that not only with Postgres, but MySQL, Oracle, MongoDB, which is not SQL by design, so you can connect to a MongoDB store, Neo4j, or even something which is not database. Stripe provides a foreign data wrapper for their API. So in fact, you can use at your model level something from your business and some data from Stripe directly to merge data using just select. So again, performance-wise, it won't be the best thing, but instead of doing that at your application level, which won't be better at all, here you can do that directly from your model with just SQL query. So it's so much better. And to conclude this presentation, I will share with you all the things you should do and not do. And I suffered from almost all of them during my technical life with PG. So yeah, it's real expertise here. First, don't use not-in. Not-in is a bad pattern, bad operator in many cases. Usually when you use not-in, usually it works locally. It works when you do some dev thing, but as soon as you're in production and you're looking and comparing things with a big set on both ends, it's very slow. So when you use not-in, I really advise you to see and watch your model and analyze if your model is meant and built to resolve the problem you have in your system instead of just mimicking the real world. It has to be there for a solution. And here, not-in for me is really a code smell. Inheritance, it has been introduced in PG around 1919. And it was because Java was very famous at that time, so they thought inheritance was a good idea. We already know in Java it's a bad practice to use inheritance everywhere, composition for the win. Inheritance in PG is deprecated, so please don't use it. Even new features are not supported with inheritance, so it's just part of the past and deprecated, but not removed for compatibility reasons. And the last one for this, timestamps. Don't use timestamps. Use timestamp with time zone. It's the best thing to do because your cluster is maybe on another time zone and you don't want to manage UTC-ish thing on your code. So timestamp with time zone. It's not the perfect solution, definitely, but it's better than just timestamp. So please use them. And thing you should use. full text search. Instead of installing an Elasticsearch or any search system, just leverage the full text search available directly in PG. So then it's the Pareto law, 40% of case can be covered with that. So you just have to enable the extension and declare what you want at your database level. Very useful. If you want to do some geographical stuff based on GeoJSON, MapJSON, and things like this, Postgres. Postgres is not the best solution in PG for that. It's the best solution in the industry for this kind of problem. So yeah, I know many people installing PG just for Postgres. And if you want to do some unstructured stuff, like MongoDB thing, but you can do that directly in PG with JSONB. You have index on it. You have the transaction part of PG, of course. You can leverage SQL, and you have the ACID concept directly into PG thanks to that. So in the end, it's way better that than any Mongo stuff deployed close to PG. And if you want to remove the application layer, because your application is just a way to move data from a database to REST API, just use something like PostgreSQL or GraphGene for the GraphQL part to expose your data. These things are opinionated, of course. There is search engine and things like this into it, but it's way better than developing something and maintaining something in the middle with CVEs, with another language. So usually I really advise that if you don't have any logic in your application. And to conclude on this presentation, PG is literally everywhere. You can run PG from a Raspberry Pi to any kind of VM on the cloud. On the Raspberry Pi, you will fry your SD card in a matter of minutes or hours, but technically it's available everywhere, and you can use that. You have no reason to not use PG because it's available and open source, of course, so you can leverage this part too. In Kubernetes, it's available. I really recommend Cloud Native PG, which is the best distribution for me to use PG. It's the original one, but it's an operator in charge of managing PG in your cluster. So the best part for the DBA thing on PG, but also the best thing for Kubernetes. So CRDs and things to declare a database, and you can manage that in your cluster thanks to it. UUIDs, it's this time a distribution, so it's a modified version of PG where they split the runtime and the storage part, and with it you can achieve something which will be in the future part of the PG itself. It's the way to distribute PG across regions, across the world, and to have something where you can leverage the scalability of system like Kubernetes. And everything for this presentation has been done and tested on AlloyDB. It's the same thing as UUID, but managed in the cloud directly from the Google Cloud part. And in Google Cloud, you have AlloyDB, which is Postgres on steroids with many features for AI stuff. So if you want to leverage that, it's also good. And you can use Crunchy, Ivan, Clever Cloud, or any provider to develop and attach your application to it, because the main thing behind it, if you deploy PG in the cloud or on-prem, you don't have to manage it. It's managed by someone else with more background on it, and then for you it's better, because as a developer I think we are not the best one to manage a PG in production. There is many things to do, and there is your state. Your state means the value of your application. If you mess with it, usually you can close your application and go back try to find another job. So yeah, please provide and ask that to people which can be better than us to do this management in production. And to conclude on this presentation, I wanted to show you how much thing we can do with PG to improve your code, improve your application, reduce the thing you have to do, because everything can be done directly from the application on the application side. And because the application has access to data, optimization can be done on this side, and it's usually way faster than doing that in the JVM, in Node, or any other runtime. So please use this part. It's way better for everyone. Thank you. I hope you enjoy, and if you have any question, I'm available for that. Thank you. We have less than 1 minute, but yeah. And don't be shy. Yeah. I'll be available and happy to talk about PG. And if you want, even online, Mastodon is my favorite platform. But yeah, feel free to ping me if you have any question. It's always a pleasure for me to talk about PG. Good. Thank you.